2 revision. We'll get on with it. Come on. Hopefully this video won't be too long. So question number 1 is with a calculator, right? Everything is with a calculator. It doesn't mean you'll use a calculator for everything, but you've got access to a calculator if you need that. So round each of the following numbers is a stupid question. It doesn't say what to round to. So I'm going to put to one significant figure. Basically round to the first digit. Round to the first digit, whatever that is. Now, on the top row, the first digit is in the tens column, so I'm rounding to the nearest 10. So 40, 20, etc., etc. In the second row, the first digit, the first significant figure, is in the hundreds column, so I'm rounding to the nearest hundred, so 300, 700, etc., etc. If the first significant figure were the first digit were in the thousands column, it would be the nearest thousand. In the units column, the nearest unit, and so on. The second one, rather than one significant figure, I'm going to do one decimal place, or 1 dp. So I'm going to be looking at the first number after the decimal point, okay, all the way through here, right? So do a couple together. What comes before the point doesn't matter. So if I'm doing A, it would be 4 point. That doesn't change. And then I've got to look at the 8 and go, right, does the 8 round up to a 9 or stay as an 8? And in this case, it stays as an 8. B, 6 point, right? It's a 1, but does the 1 round up to a 2 or stay as a 1? Well, the 1 is followed by a 9, so in this case, it's going to round up to a 2. Okay, so first question, round into significant figures or round into decimal places. Reading scales, right? Got to be able to work out what we're going up in, all right? First one, fairly obvious. We're going up in tens, and between each 10, there are 10 little lines. So each little line is worth 1, so that's 25. But in B, we're still going up in tens, but there are only 5 little lines, okay? So if I start at 40, there's 1, 2, 3, 4, 5 jumps to get to 50. So we're going up in twos. So this is 54. Here we're going up in hundreds, but 5 jumps again. 1, 2, 3, 4, 5. So 100 divided by 5 means we're jumping in 20s. So that's 780. And then probably the most difficult one here, actually, because the jump is in 100, okay? Now, there's a couple of ways to do this. Some people might like to write missing numbers in, like 50, 25, and you'll soon work out, I guess, we're going up in 5s here, so that one is pointing at 45, which is 1 below 50. Okay, don't rush that question. You'll get it right, don't rush it, okay? Dot notation, keep it simple. The 5 is recurring, so it gets a dot above it like that, okay? In the last question, for example, the repeating bit is 72. It goes 72, 72, 72, 72. So they both get dots. I think one thing that is missing here might be something like this. Okay, just be aware of it. Where the 17 is repeating, but the 4 isn't. So if I was writing this with dot notation, the 4 wouldn't get a dot, but the 1 and the 7 would, because they recur, they repeat as the number goes on. Okay. Nth term. This is going up in 3s. This is going up in 5s. This one is going up in 2s. Okay. This is the 3 times table. This is the 5 times table. This is the 2 times table. The nth term, therefore, is 3n, 5n, and 2n. However, for those, and I know you're pretty good at this, a lot of you, okay, you also need to work out how much more than the 3 times table each number is, or how much more than the 5 times table each number is, okay? So what we need to do is go backwards a number. Think about working down the sequence, 14, 11, 8, 5, right? If we were coming down in 3s, this number here would be positive 2, and that goes on the end. Or if we were coming down in 5s, the number back here would be positive 4. And a slightly more difficult one, if we were coming down into 7, 5, 3, 1, then this number actually would be negative. It would be minus 1, and that goes there. Okay. The flip of this question is that they might give you the nth term, for example, 5n plus 4, and you have to write out what the sequence was. Okay. So if we were doing that, the first number in this sequence would be 5 times 1 plus 4. which is 9, which we can see here. The second number would be 5 times 2 plus 4, which is 14, which is the second number there, and so on. 5 times 3 plus 4, 5 times 4 plus 4. So be prepared for them to give you the nth term, and you have to work backwards and actually write out what the sequence is. Okay, simplifying. I think we possibly need to look a little bit more tricky than this. Let's just do the last one to begin with, though. Okay, or this one. We're basically collecting things that are the same, right? The big mistake with adding and taking away is make sure you don't write m squared, a squared, b squared. That is when we are multiplying, okay? Mr. Crane is added in here too. Here we've got 7m plus 7p. Turn this off. Okay. 7m plus 8m, okay, which is... Right, I'll tell you what I need to do. Hang on a second. File. We need to save this. I'm not going to stop the video. You're just going to have to bear with me because at the moment we've got 2 people editing the same document. Okay, I should be all right now, hopefully. Yeah, okay. Right, my apologies for that. That's delayed you a minute, but here we go. We're back on board now. Okay, so this is where we're at. So if I collect my m's together, I've got 15 m's, right? Then I've got 7 p's, add another p, add another 2p. So in total in the answer, I've got 15 m's plus 10p. We need to be careful with and take my negatives. So if I do something like 3a plus 2b minus an a and minus 5b, quite tricky, okay? Start with the a's, 3a, but this time I'm not adding any a's on, I'm taking an a away, so I'm down to 2a. And with the b's, I'm starting with plus 2b, but I'm taking away 5. I'm taking away more than we've actually got. 2 take away 5, so actually we go down into the negatives here, down to minus 3b. Now there's something else missing from this revision sheet, because we did it in paper 1. If I was asked for something like this, okay, I would multiply the numbers. 3 times 2 is 6. Then look at each letter separately. Now this is times in, this isn't adding or taking away. Okay, so the a's, I've got a squared times a cubed. And like we did in paper 1, if we're times in the same letter, we add the little numbers. And the same with the b's. We've got 1b there and another 5 there. So if I add the 1 to the 5, I get 6. And the same with dividing. I've got 8a cubed divided by 2a. I'll put another extra letter on. Let's do some b's here as well. We'll put a b to the power 7 on the top, and we'll put a b squared on bottom. First of all, divide the numbers. 8 divided by 2 is 4. But when we're dividing, we don't add the indices, we take them away. So for the a's, it's 3 take away 1. And for the b's, it's 7 take away 2. Percentages of an amount. Now you've got a calculator, guys. You've had a calculator for all these things, but I don't think so far a calculator has really helped you. Probably the first time it will, okay? With a calculator, I would always take the number, right? And effectively what you're doing, right? I almost think, you almost could think of percentage as out of 100. 9% is 9 out of 100. 45% is 45 out of 100. 17 again, right? So to find, let me cross that 80 out because it's right. So if we do this last one here, into my calculator, I would put the 540. I would divide by the bottom, divide by 100. In other words, what we're doing when we divide by 100, we're finding 1%. So take the number, divide by 100 to find 1%, and then times by the top, times by the 17 to get 17%. I'm not actually going to put the answer into that because I haven't got a calculator with me, which is stupid, really, for a calculator paper. So this one, think about what you'd put into your calculator for C. And hopefully you're thinking, I would put 135, I would divide it by 100 to get 1%, and in this case, times it by 45 then, to find 45%. Okay? Expanding and simplifying. Right. This bracket here is times in by 5. This bracket here is times in by 2. If I times these both by 5, I end up with 5y's and 5 3's are 15. If I times this bracket by 2, I end up with 2y's and 2 7's are 14. That's the expand bit. The simplify bit is what we did here. Right? That's simplifying. It's bringing things together. 5y, and this time it's adding another 2y, so there's 7y. And then we've got the number 15, and we're adding 14 onto it. So we've got 29. So adding the y's and then adding the numbers. And it's the same with this one. Right? If we times the first bracket by 6, we get that. And if we times the second bracket by 9, we get that. And then we will add our w's. And then we will add our numbers, 30, add 18. Proportion. You've got a calculator. Keith buys 6 pencils for 90p. So 1 pencil is 90 divided by 6. Once you know the cost of 1 pencil, you can work out the cost of 1, 5, 11 easily. Same here. Jack and Harry are waiters in a restaurant. They are both paid the same amount of money for each hour that they work. Jack worked 6 hours and is paid £48. So let's work out what he's paid in 1 hour, like we worked at the price of 1 pencil. Divide the 48 by 6, so he is earning £8 per hour. If his mate who is paid the same amount works 8 hours, then we then need to times that by 8, because it's £8 an hour and he's working 8 hours. Yeah, trickier now. Getting into some trickier stuff. Yeah, we're getting into the second half of the paper where, you know, we're up to the harder stuff, definitely. Okay, my best gut feeling here is to change them all to percentages. So this one doesn't need changing, it's fine. This is 19%. This is not 3%. You always have to think of it as it's 3/10, right? So it's 30%. Okay, same over here. That's already done for us. But that is 90%. And that is 79%. So easy enough to change your decimals into percentages. Okay. Then changing fractions though. This is where we have a bit of an issue. Okay. As I just said, right, percent means out of 100. So what we really want is we want these fractions out of 100. But my first fraction is out of 20. So to get the 20 to be 100, to change the denominator from 20 to 100, I need to times it by 5. But if I times the bottom by 5, I times the top by 5, and on my calculator, 5 17s are 85. So that is the same as 85 out of 100, which is 85%. And to get this one to be 100, I have to take the 5 and times it by 20. So I do the same to the top, which is 80 out of 100, which is 80%. Now they are all percentages. I can put them in order, right? 79 is the smallest, number 1. 80 is next, number 2. 85 is next, number 3. 88, number 4. And the biggest one we've got there is 90%, number 5. Okay. Volume. I think we'll concentrate on C, both C's. Yeah, okay. To get the volume, we need the area of the front. Base times height divided by 2. Volume is not front, back, side, top, bottom. That is surface area, okay? Volume is the area of the front times the depth, okay? 7 5s are 35. You've got a calculator, 35. Half of 35 is 17.5. Use your calculator. And once you've worked out the area, 17.5, times it by 4. And it becomes 70 meters squared. And for a cylinder, okay, and I'm doing the last one, even though it's probably the hardest one, it's the area of the circle times the depth. So this would be pi times the radius squared. Now, in the first two, it is the radius we're given, 4 and 7. But in this last one, we're actually told the diameter all the way across. So what we need to do is half that. We only want halfway. So we're going to do pi times 10 squared. Okay, into your calculator, remember pi is 3.14 times 10 squared. That would give you the area of the circle, and then times that by 25, which is the depth. So volume is work out the area of the triangle or the area of the circle, and then times it by how deep or how far back the shape goes. Okay. Trial and improvement we've done very recently, right? B is probably a better one to start. Okay, if it's between 9 and 10, here's your setup. You're going to write your trial, or your try, I might have called in class, then your method, and then your evaluation. That's the only way to get full marks here. So to begin with, we're going to try the middle, 9.5. So in this case, it would be 9.5, I don't know why, I like brackets, but then squared, minus 5 times 9.5. Okay, and I'm looking for the answer 40, but when I put that in my calculator, if that is bigger than 40, I write too big, or if it's lower than 40, I write too small. Okay, and if it is too big, I make my trial lower, 9.4, or if it is too small, I make my trial bigger, 9.6, and I either then come down and 9.5, 9.4, 9.3, 9.2, or I go up, 9.5, 9.6, 9.7, 9.8, okay, until I get to either side of 40, right? One answer lower, one answer bigger, okay, and then you do your check, and you tell me which one is closest to 40, right? Don't get these mixed up. This was volume. Now we're going to do surface area. Now this is front, back, top, bottom, side. In these cases, sides. We've got a front and a back, a top and a bottom, a side and another side over there. So the front is 5 times 2. The back is 5 times 2. The top is 5 times 4. The bottom is 5 times 4. The side is 4 times 2. And the other side is 4 times 2. Work them all out separately. Use your calculator if you need to. And then add them together to get the total surface, the area of all the surfaces. Okay? Similar shapes. Right? We're looking for a pair of sides we know. So we know this. Oh, we don't know that. We don't know that, but we know that one. But if we look at the top, yeah, great. We know the top of this one and we know the top of this one. That allows us to get what's called a scale factor. The bigger one is 10.5, and if I divide that by 3.5 on my calculator, that'll tell me how many times the littler shape goes into the bigger shape. How many of these 3.5s make 10.5? Now, you might get a nastier number than this because you've got a calculator. This is quite nice because it is 3. But you could come up with something like 2.4 or 1.6 or anything really, okay? So to work out the length of EF, which is here, I would do 5.2, which is here, and I would times my scale factor. And for the second part, to work out the length of AD, which is here, I would take 19.2, which is here, but because I want to find this on the smaller side, I'm not timesing by 3, I'm doing the opposite of that. I'm dividing by 3. And again, use your calculator to get those two answers. Same on this one, guys. Look at that shape and go, well, which pair am I going to use for my scale factor? Okay. Hopefully you go in, right, the pair I know is this and this. I'll put 15 divided by 6 in my calculator is 2.5, right? X is 8 times 2.5. Y is 25 divided by 2.5. But you've got to get that scale factor first. You've got to find that pair that you know that you can divide. And lastly, right, there is trigonometry in this, right, but I'm not going to go through it here. If you want to do that, you might have to go into Corbett Math or something separately. What I am going to do here is Pythagoras' theorem. And on this one, I'm going to put 10, 6, x. And on this one, I'm going to put 6, 8, x. If you're finding the diagonal side with Pythagoras' theorem, if you want to know the length of the diagonal, the big side, the side that you sometimes call, or we call in class, the hypotenuse, okay, then it is square one of the smaller sides, square the other smaller side, 8, add them together, 100, and then use your calculator to square root, find that square root button, put 100 inside it, and that will tell you that the answer is 10. Might be horrible tomorrow, might be a decimal again, okay? Could be anything, right? But just follow that method. Square, square, add square root. Or if you know the diagonal side, if you know it, and the side that you're being asked to find is one of the littler sides, the base or the height, same method, square 100, square the other side, you know, 36, but instead of adding them, take them away from each other and then square root, and the answer is 8. So that is plenty to get you through the exam. Then there's a little bit of SOHCAHTOA. Again, you might want to go into Corbett Maths or Google a little video on trigonometry if you've got time. I unfortunately haven't got time to run through that, and it's something we've done in class a little bit as well. But hopefully that's helped, and good luck for tomorrow. Remember to use your calculator where you can and where you need to.